Hi there, Year 13s. In this video we're looking at numerical integration. Had the wrong slide there. So in particular we're looking at the trapezium rule. And the essence of this rule is for when we want to find the area under a curve over a specific interval, we approximate that area by turning it into a series of trapeziums. And that's how we find an approximation for the area. And we do this in a case when we can't integrate a function. So here's an example of a function that can't be integrated directly, and so we use this method to get an approximation for it. This h here, this is our interval, or the step that we go up in. So for this example here, we're going across 0.5, and we'll do 5 intervals here, and so we'd be dividing by 5, which means that we're going up in steps of 0.1. And then we've got this formula that we can put all our heights of our trapeziums into, and that effectively works out the area of all of the trapeziums. So quite an interesting task for you might be to take this diagram and see if you can derive this formula using the area of a trapezium. But I'll leave that for you in your own time. Let's have a look at this example here. So the reason why we'll go up in intervals of 0.1 is pretty arbitrary. Usually you'll be told what intervals to go up in, but 0.1 is a good sort of one to start with, just for an example. And usually, yeah, like I said, you'll be told what to use. Okay, so what I'll do is I'll make something here for, or a label here for each of our y values that we're going to calculate. 2, 3, 4, and 5. And our x values at each of these points, and our y values at each of these points. So our first x value is going to be 1. And we have 1.1, 1.2, 1.3, 1.4, and 1.5 will be our last. And so to work out what y is going to be in these, we want to put this into our calculator and work it out for each. So our first one will be 1 sine of 1, which is 0.841. And if you want to do this bit faster, you can go into your table mode of your calculator, put the function in like I have here, go to set, start at 1, finish at 1.5, and go up in steps of 0.1, and it will give you the rest of the points. We just need to put that in, and you can see there are the rest of the points. So I'll go ahead and put those in. Okay, so there's all those values in. Once you've got those values in your table, you can start to think about writing out the formula. So my integral from 1 to 1.5 of x sine x is approximately equal to, that's what the wave equals are for, a half times my increment, which is 0.1, all timesing my y1, which is 0.841, my yn, which is my last value, 1.50, plus 2 times the rest of the values. So there's my completed formula. And after that, I want to put this into my calculator, and the only thing I'll warn you about is it's quite important to use as accurate values for these as possible. And so when you're working it out, if you go 1 sine 1, you want to put that into your memory, and then do the same for 1.1 sine 1.1, put that to your next variable, and so on. Okay, so now I've got all those values in my calculator. I can substitute in what I've got for the formula. So I've got a half times 0.1 times our first value and adding to our last value. That should be our last value. There we go. Plus 2 times all our other values added together. So C plus D plus E, I've missed B, so I'll put B in as well. Okay, and that gives us 0.59 if we round it to 2 dp, so that's approximately equal to 0.5 0.59. Now at this point you want to consider how close it is to the real value, and so our calculator can integrate this function precisely, and so we'll see what that comes up with when it integrates it. So we'll put in x sine x and we'll go from 1 to 1.5, and that gives us 0.59, so we can see that to 2 dp we're correct, and if you look at the above value it's pretty close. So even across 6 intervals we can get quite a close approximation using the trapezium rule. You might ask then, if our calculator can do it, why do we bother with the trapezium rule? Well, ask me in class, but essentially you might be the ones programming the calculator, so you would need to have some numerical method up your sleeves. Okay, so there's some work for you to practice the trapezium rule. Have some fun with that.